Okay, this is the solution for Frappy 3. A sociologist was investigating the ages of grandparents of high school students from a random sample of 10 high school students. The sociologist collected data on the current ages and years of the students' maternal grandparents. The data is shown in the table below. All right. So part A says construct and interpret a 95% confidence interval for the population mean difference in age. That's the age of the grandmother minus the age of the grandfather for the maternal grandparents of high school students. So we first need to decide if we have a two-sample t-test or do we have a matched pair t-test. And the big thing to realize is the grandmother and the age of the grandmother and the age of the grandfather independent of each other. And since they are generally, it's considered a married couple, married couples are not independent. So because this is not independent, then it can't be a two-sample. It has to be a matched pair. So the first thing, let's do our parameters. Let the mu of D equal the difference in ages of the grandmother and the grandfather. Okay. So now let's do our conditions. So the first thing is we need a random sample. And it tells us and that's a random sample of 10 high school students. Okay. Then we need to know is the number of in the sample, is it less than 10% of the population? And we need to do it separately. So 10 is less than 10% of all grandmothers. And 10 is less than 10% of all grandfathers. Again, remember, we have to do them separately for this part. Now, because n is equal to 10, we're going to need to do a normal probability plot. So I'm going to bring out my calculator, and I am going to go to Stat, Edit, and I'm going to type in the differences. Because we're doing a match pair, we just need the differences. And that's 1, enter, -5, enter, -10, enter, 8, enter, -5, enter, -8, -3, -4, and what else we got over here? And 4. All right. So now let's do our normal probability plot. We're going to go second, stat plot. Okay. And let's see here. I have not done a scatter plot on this before. There's our normal probability plot. And we're going to use the list 1 in our x-axis. Okay, and now we're going to go second, and we're going to graph it. Oh. Check our window. Hold on here. It's not quite like the second format. Okay, why am I not getting a normal probability plot? Oh, there it is. I just got to zoom out. Okay, And that looks fairly straight. So now we're going to sketch that on our paper. Now this is just plotting the differences, and that is fairly straight. We do need fairly linear. Okay. So conditions are met. For a paired t interval with degrees of freedom equal to 9. Remember, the degrees of freedom is 1 minus your sample size. Alright, so let's pull our calculator back out. Let's go to Stat, Test, and we want the t interval. Okay, and sorry about that. We have the data. It's already in our calculator in list 1. All right, and we want a 95% confidence interval, so that's already there. And there's our interval. It's already right here on our screen. So our interval is from negative 5.956 955 to 2.355. All right. All right, so now that you have your interval, you need to interpret it. So you can say, I am 95% confident the true mean difference in ages of high school what was the original question? The original question was of maternal grandparents of high school students in ages of the maternal grandparents of high school students is between, and I'm negative 5.955 years and 2.355 years. Okay? All right. So that's part A. Part B. One of the sociologist's research questions was about the mean difference in age without regard to which grandparent is older. So it didn't matter which one was older. So what that's telling us is we're not always doing grandmother minus grandfather. We're sometimes also going to do grandfather minus grandmother. We're just getting the differences. So we're looking for the absolute value. The interval construction part A does not address such a question. Based on the sample of high school students, give the value of the point estimate for the mean difference in age. So it's looking for the mean difference in age. So we're looking for the mean. So we need our values, and that's 1. And so the next one's a negative 5. But we want just the difference, so it's a 5. Plus 10, plus 8, plus 5, plus 8, plus 3, plus 4, plus 4, plus 4, all divided by 10. If I add all those together, I'm going to get 52 divided by 10. And so the true The point estimate for the mean difference is 5.2 years. Okay. All right, so this is Frappy 3. If you have questions, make sure you talk to me